Hello, everybody. In this lecture, we will address the measures of associations used in research. And basically, when we say measures of association, it's a measurement that is looking at the relationship between the independent variable and the dependent variable, namely the exposure and the outcome. So it's a methodology developed by researchers to figure out how can I quantify the association, the relationship between the exposure and the outcome, their direction, and then also at a later point try to see if this association is statistically significant. To do so, we need to review some concepts or some ideas. So we're going to start off with something called a relative risk. And to do so, we're going to start talking about what is a risk. And basically, a risk is the probability of developing the disease. To be able to calculate a risk, you need to look at incident cases or new cases, not prevalent, not those that already exist, but they have to be new cases. In other terms, you have to start with a group of people that do not have the outcome, wait for a period of time, then some new cases show up, then you use these new cases, these incident cases, you divide them by the total, you get an incidence rate, or what is called also as a risk. And therefore, the two design that allow you to do that are the cohort. يعني basically, they have to be prospective design. Cohort أو experimental design, RCT. Okay. So basically, this is how it works. You have a group of people free from the outcome, and as time passes, some of them will remain free and some of them will develop the outcome. So these will be the new cases. The number of the new cases divided by everybody is called a risk, or also an incident. These are the incidence rate. So how is it done? All right, so let's look at this example. A study recruited 4,000 participants, all free of stroke. After 3 years follow-up, 100 developed the stroke. Therefore, the risk of stroke in this sample is 150 divided by 4,000. It's 0.0375. That would be the risk of stroke. The 150, the new ones only على total على 4,000. This is also a definition of probability. So it's like the probability of stroke in this group, as long as you make sure that you're only looking at new outcomes. So how is the risk different from the prevalence? Study surveyed 4,000 participants and asked if they ever suffered from stroke. 150 reported that they had had a stroke, and therefore the prevalence would be 150 over 4,000. The same number, everything is the same, except that this time you're not looking at new cases, you're looking at cases that already exists. So prevalence is not the same as incidence, and therefore, when your design is not a prospective design, when your design is namely cross-sectional design, what you're going to end up calculating is a prevalence, not a risk. So again, stating out the obvious once more, prevalent is not equal to risk. Existent cases على everybody is a prevalent, it is not a risk. A risk requires that you only have new cases, and it requires that the design itself is a prospective design. Alright, هلا في شيء اسمه odds that is a bit different than probability. If you remember, probability is by definition a success على all possible outcomes, and the probability of a girl is 1 over 2 because there's only there are two possibilities, boys and girls, only one of them is a success. So 1 over 2 is 50%, that would be the probability of a girl. However, the odd is success على failure, which is quite different than probability. So the odd of girl is 1 over 1, yani 1 to 1. That would be the odd, which is quite different than a probability. So let's see a little bit of application of the odds. So كمان 4,000 people followed in time in a prospective design, 150 developed stroke, while 4,000 surveyed and 150 reported a stroke. It doesn't matter this way or that way. The odd of stroke in both would be 150, the outcome, على الفيلير يعني اللي ما عندهم السtroke, which is 3,850, which in that example is 0.039. So the odd is quite different from a probability. It's the success على failure, whereas probability is success. Everybody, when we're talking about risk, we're calculating something that resembles risk probability more than it resembles odds. odds and probability are related. If you think about the formula, odd is A على B, whereas the probability is A over A plus B. Okay? If you take the odd and you divide both the numerator and the denominator by A plus B, so يصير عندنا A على A plus B divided by B على A plus B, and therefore this is the probability right here, and this is the complement of that probability, and therefore the odd is nothing but the probability divided by 1 minus the probability. Okay, so how does that work? Well, you probably remember by now that the probability goes from a value of 0 to 1. Okay, so starting with the probability of 0 and going all the way up to 99. I'm not going to go all the way up to 1 because that will create some problems in calculating the odd. But just to illustrate the point, if this is the probability going from 0 all the way up to 1, then the 1 minus probability is the opposite. So بالبottom عندي 1 and at top I have 0.01. And therefore you can calculate the corresponding odd for every probability. Okay, so starting with the probability of 0, the corresponding odd is 0. The probability of 0.1, the corresponding odd is 0.11. The probability of 0.2, the corresponding odd is 0.25, and that will go all the way up to you reach the 50% probability. So when you have a 50% probability, the odd becomes 1. And once the probability starts going above the 50%, therefore the odd starts becoming greater than 1, and it escalates very rapidly into reaching values that are very, very large. So though the probability is bounded between 0 and 1, the odd is bounded between 0 and plus infinity. Okay? And right at the middle, where when things are equal, a probability would reduce to 50%, the odd would be equal 1 to 1. Okay? All right. So this is, in a very brief way, the odd, because we're going to calculate something with the odd in a minute. Okay, so we introduced Shumaneta risk, we introduced Shumaneta probability, Shumaneta odd, Shumaneta prevalence. Let's move into calculating a risk. So here you have a prospective design. Okay, so you have those that were exposed and those were not exposed, yani experimental group, non-experimental group. They were followed into time. We set up the table this way. Some of the people will get the outcome, some of the people will not get the outcome, and therefore your contingency table, your two-way contingency table, two-way, and you have one variable exposure and one variable outcome, is A, B, C, D. Okay, the total of exposure A plus B, the total of non-exposure is C plus D, the total of outcome is A plus C, the total of absence of outcome is B plus D. Okay. All right, so here's an example. We have those taking drug, those taking placebo, and they were the total taking drug is 3,270. Those taking placebo is 2,730. Out of those that taking the drug, 680 developed myocardial infarction, and out of those taking placebo, 1,200 developed myocardial infarction. And you can calculate in this example the risk of myocardial infarction in those taking the drug, and the risk of those taking myocardial infarction in those taking the placebo. So what we're going to do actually is we're going to calculate two risks, one for the exposed and one for the not exposed, one for the treated and one for that not the treated, and we're going to compare these two risks and see how much of a difference there is between them. Okay, so here's let me try to see if I can get rid of okay, so this is the table we were looking at, and as I said, we want to calculate the risk of the myocardial infarction in the treated. So that's the new cases of myocardial infarction, 680 divided by the total, the 3,270. We also calculate the risk in the placebo, which is 1,200 divided by the 2,730, and that will give you the risk in the placebo. Now I have two risks, those taking the medication and the risk of those not taking the medication, and now I can compare both of them. Okay, so risk calculated in the drug, who are risk in the exposed, R with a small e next to it, just to say that exposed, and it comes out equal to 0.208. So if you're receiving the drug, the risk of myocardial infarction is about 20.8%. If you're not taking the medication, the risk in the not exposed, so R with NE next to it, is 0.44. So if you do not take the medication, your risk of myocardial infarction for the period of the study is 44%. And now what we do is we need to compare these two risks, one, one versus the other. One thing that comes to mind is maybe like taking the difference between the two, which might work. However, we're going to do something different, is that we're going to actually calculate a ratio of the two. So we put the risk in the exposed ala risk on the non-exposed, creating something called a relative risk or a risk ratio, same thing. And that comes out to be equal to 0.47. Now, how do we interpret a relative risk? If the risk in the exposed and the risk of the not exposed were equal, the ratio will be equal to 1. If the risk in the exposed is lower than the risk in the not exposed, as the case that we just saw now, the relative risk will be less than 1, as the example here. However, if it was the other way around, the risk in the drug higher than the risk in the placebo, the relative risk will actually be greater than 1. So you get a value greater than 1. So let's look at the second slide and see if that covers what we talked about. A relative risk is a measure of the magnitude of the association between the exposure and the disease. So it measures the magnitude. كلمة relative risk moves away from 1. كلمة association between the exposure and the outcome is said to be stronger. هلا when the relative risk is greater than 1, there is a positive association. يعني the relative risk is indicative of a positive indication. يعني the more exposed you are, the more outcome you get. When the relative risk is less than 1, we talk about a negative relationship, and that means the more you are exposed, the less you get the outcome. A relative risk may assume a value between 0 and infinity. That's theoretically speaking. However, what is important is that the value 1. Value 1 is indicative of a no association between the exposure and the disease. In exposure less than 1 is indicative of that the drug or the exposure or whatever is protecting from the outcome, and indicative of a protective effect of the exposure. When the values of relative risk are greater than 1, this is indicative of an increased risk of the disease among the exposed. هلا remember we're working in a sample, and therefore the results you're getting are values that are just true for the sample. معناتها these are estimate, and therefore to extrapolate these results to the population, to be able to say that whatever you observed in the sample is actually present in the population, you need to check if your relative risk is statistically significant or not. And this is done by either doing a p-value, okay, or building something called a confidence interval for the relative risk. And we're going to discuss this in the next slide. Okay, so confidence intervals. Maybe I need to let me show what I mean by this. Okay, so quick overview. You know that any research study is built on a sample coming from a population. So this is the population over here. When you're doing your study, you take a sample and you're working with this sample over here. Now, in this sample, you are calculating your relative risk the way I showed you. However, in the population, there is a real relative risk. Okay, so there is the real relative risk. Okay, okay, so this is the real value. This is nothing but an estimate of the real value. Okay, now every time you have an estimate, you can actually build something called a confidence interval around it, and this is done very simply by using the following formula. The formula says you take the estimate, and around it you build fences going up and down, okay, hoping by doing so you will be able to capture the real population value. So you take your estimate, so maybe your estimate, let's say, is 2. So you take your relative risk equals to 2, you build around it a confidence interval up and down, hoping by doing so you will capture the real relative risk. Now, how sure are you that you doing this you will capture the real one? Well, this is the percent confidence. So based most of the time نعمل شيء اسمه 95% confidence interval, meaning that you're 95% confident that the real value is inside the interval you just created. Okay, so that's called a 95% confidence interval. So the 95% confidence interval is building a fence around of your estimate, so whether it's a relative risk or anything else. Okay, and by doing so, you are saying that you're 95% confident that the real value in the population is inside. So maybe your relative risk came out to 2, and the confidence interval is from 1.4 all the way to 3.1 مثلا. Okay, so you say that in my study, I found the relative risk equals to 2. So in my study, the risk in the exposed is twice as bigger, twice as much as the risk in the non-exposed. This is in my sample. I am 95% confident that the real relative risk that exists in the population is somewhere between 1.4 and 3.1. Why I say this? Well, I'm saying this because remember, if if in fact there was no difference between those exposed and not exposed, and لو كان الريسك in the exposed is equal the risk in the not exposed, the relative risk will be equal to 1. Okay, so the value 1 for a relative risk is indicative of no association. Okay, why is this important? Because when you're going to build your confidence interval, you're going to ask yourself, does my confidence interval crosses value of 1 or not? يعني let's suppose بدل ما يطلع confidence interval 1.4 ل 3.1, let's suppose it came out to be 0.8 and up to 4.2. That what that means, it means that you're 95% confident that the real value in the population for the relative risk is anywhere between 0.8 to 4.2. But that means that the value 1 is inside the interval. So therefore, value 1 is a possibility. There is a possibility that in the population, in reality, the relative risk is equal to 1. So it's part of the interval. Yani all the values inside the interval are possible values for the relative risk. And therefore, بما أنه the relative risk of 1 in the population is a possibility, then you cannot ignore that. And therefore, you cannot declare that your results are statistically significant. You cannot declare that the association you observed in the sample is substantial and it exists in the population, because in fact, once you build your confidence interval, there's always a possibility that there is no association. However, if we come back to the example where your relative risk did not include 1, so value 1 in this instance is not a value that is is considerable in the, so you're even as low as 1.4, your relative risk is still different than 1. So in that scenario, the real relative risk cannot be equal to 1, and therefore you declare that it's statistically significant لأنه you're sure that there is an association between the exposure and the outcome, since the relative risk of 1 اللي هو indicative of no association is rejected, since it cannot be in the population equal to 1 because your confidence interval is not included, and therefore you would conclude that your relative risk is statistically significant. So let me recap that quickly. When you're calculating a relative risk, you're calculating it based on your sample. So if your relative risk in the sample, and then you build around it a fence, and then you look if value 1 is included or not. If the 1 is included, then value 1 is a possible value, and therefore you have to say that there is no association. Okay, you say there's no association, yani the results are not statistically significant. They're not significant. Okay, هذا the case where 1 is included. However, if 1 is not included, So if 1 is not included, not included, therefore value 1 is not accepted, therefore value 1 is rejected, and therefore you say that there is an association and the results are significant. Okay? So, by the way, in this instance, when in the relative risk, the null hypothesis states that there is no relationship between the exposure and the outcome, and therefore the null hypothesis says that the relative risk, the real one in the population, is equal to 1. Okay? The relative risk is equal to 1. And therefore, if 1 is a possible value, you fail to reject the null hypothesis. You fail to reject that, and you declare there is no association, no statistical significance, and you declare that the results you obtain is due to chance only. However, in the event where your confidence interval does not include 1, and therefore value 1 is rejected, in this scenario you will reject the null hypothesis, you will reject this, and therefore you declare that there is statistical significance and there is an association. Okay, so that's why when you're doing a confidence interval, you look for value 1, whether it's inside or outside your interval. If it's inside, no statistical significance. If it's outside, there is statistical significance. And the value 1 is not a magical value. Value 1 means the risk in the exposed equals the risk in the not exposed. Okay? Um, Let me do one more thing just so that it's perfectly clear. So if you look at the continuum of the relative risk, the continuum of the relative risk, it goes, as we said previously, from 0 all the way up to 1, from 0 all the way up to 1. And no, I'm sorry, I'm sorry, all the way up to infinity, passing through 1. So هذا الكونتينيوم sorry هذا الكونتينيوم of relative risk. This is a 0 and it's going up to very large value. The 1, let's say the 1 is here. Okay, so anytime you have a confidence interval that does not include the 1 is statistically significant, whether it's on this side, like this is a confidence interval and only 0.6 to 0.8, that's a statistically significant, or if it's on that side, so من هون لهون, so maybe 1.2 ل 2.5. Okay, no matter on which side you are, it will be statistically significant. The only difference is that here it's indicative of a risk relationship, yani a positive association. Here it's indicative of a negative relationship. However, a confidence interval that starts before the 1 and ends after the 1 is non-statistically significant. Before I come back to the lecture notes, let me just quickly point out something. So when you're looking at a confidence interval, do you always look for 1 as your sign for if it's statistically significant ولا لا? In fact, you have to know what it's a confidence interval of what. If you're looking at a confidence interval of a ratio, مثل relative risk. So relative risk, as you know by now, it's a ratio. It's a risk in the exposed على risk in the not exposed. When the risks are equal, it's equal to 1. Yani under the null hypothesis, this is going to be equal to 1. And in that instance, you will be looking for value equal to 1. However, if you're looking at a difference, so risk in the exposed minus the risk in the non-exposed, as a risk at bottom in this scenario, then the difference will be equal to 0 according to the null hypothesis. And in that scenario, in the confidence interval for the risk difference, you would be looking if it crosses 0 or not. Okay? So every time there is a ratio, you look for 1. Every time there is a difference, you look for 0. It doesn't have to be risk. It could be average difference. So maybe you have the mean of a certain something in the exposed minus the mean of something in the not exposed, and therefore you're calculating a mean difference. According to the null hypothesis, the mean difference is equal to 0. And again here, you would be looking if the confidence interval crosses 0, not if it crosses 1. So whenever you're looking at a confidence interval, if you want to know if it's statistically significant, ask yourself, is this for an estimate that is a ratio, or is it for an estimate that there's a difference? Is a ratio, we're looking for value 1. If it's a difference, we're looking for value 0. So I think, Hike, I gave you an overview of how it works. Let's go back to the lecture. Um, so confidence intervals are used as measures of statistical significance for the relative risk. You will see the same thing for odds ratio. هلا بنحكي عن odds ratio بعد شوي. But you know, by the name odds ratio, then it's a ratio, and therefore we're looking for value 1. Is a confidence interval for relative risk or odds ratio containing value 1 is indicative of no statistical significance, and I explained why. This is because the null hypothesis states that the real relative risk in the population is equal to 1. Therefore, if the confidence interval contains 1, this value cannot be rejected, and thus the null hypothesis cannot be refuted, and therefore you cannot declare that there is an association in the population. You're only seeing an association in your sample, and we say that this association observed in sample is due to chance only. So here's kind of like the same thing I showed you a minute ago. That's the 0, that's the 1, and I'm having here A, B, C, D, E, F scenarios of relative risks with their confidence interval. The arrows are the confidence interval. And if you want to pause the video for a bit and try to figure out which of these are statistically significant, which are not, and also try to figure out among the statistically significant which one are indicative of a positive association and which one are indicative of a negative association. I did say on purpose among the statistically significant one, لأنه if your confidence interval is indicating that there is no statistical significance, there is no point saying if it's positive or negative, because either way we're saying in the population ما في association. So إذا بدكم pause the video now, and I'm going to give the answer now. A is statistically significant because it's not crossing 1, and it's a positive association. B, it's statistically significant, كمان for the same reason, not crossing 1. However, it is a protective relationship. It's a negative association. C is not statistically significant, مع إنه the estimate calculated in the sample appears to be greater than 1. However, even though the estimate appears to be greater than 1, when we created a confidence interval, it did cross the value 1, and therefore we declare that this estimate is due to chance only. D is also statistically significant, and it's also on the negative side. E is not statistically significant, but if I were to guess, it probably was a relative risk that is less than 1, yani indicating a negative association. However, since the confidence interval crossed 1, we declare that this relative risk measured in the sample is not a real one, it's due to chance only. F is statistically significant, and if it's indicative of a positive association. So here's another example. This is another application. We're looking at women using oral contraceptives and women not using oral contraceptives. We followed them over a period of time, and we're looking for development of MI. So in this example, we're going to calculate the risk of myocardial infarction in the users of oral contraceptives versus the non-users, and let's see what happened. So the risk in the exposed, we'd look at the exposed, and the 23 MI divided by 327, that is 0.0703. So the risk in the exposed is about 7%. However, in the non-exposed, I have 133 MI على total 2,949. That gives me a risk of 0.0451, يعني the risk of about 4.5%. Obviously, in this example, if a woman uses oral contraceptives, her risk increases from 4.5% less 7%. Therefore, I can calculate the relative risk, or the risk ratio, by taking the risk in the exposed, dividing it by the risk in the not exposed, and I get 1.56. So what does this 1.56 means? What it means is that so far, my relative risk greater than 1 indicative of a positive association. However, before I do any interpretation, I need to calculate the confidence interval. Over here, that's the same example. I have the relative risk, and I'm looking at the 95% confidence interval. So the 95% confidence interval has a lower limit of 1.017 and an upper limit of 2.39. The interpretation of a 95% confidence interval means that although in my sample my relative risk came out to be 1.56, in the population, I'm 95% confident that the real relative risk is somewhere between 1.02 all the way up to 2.39. I don't know exactly where it is, but I'm 95% confident it's somewhere between these two values. Okay, now let's interpret the results and let's see if we can say something about if it's statistically significant. Well, and maybe let's start with that. Does the confidence interval crosses 1? لا, it does not cross 1. The lower bound is a bit higher than 1, and the upper bound is much higher than 1. So it does not cross 1, and therefore it's not statistically significant. It does not cross 1, and it is statistically significant. And therefore I can now interpret my relative risk. This relative risk is 1.56. So فيني أقول the risk of myocardial infarction among the oral contraceptive users is 1.56 that of non-users. You could say it. Or you can say that the OC users have a 56% more risk of developing MI than those non-using. هلا من وين جبت أنا ال 56%? I compared the 1.56 لل 1. 1.56 is higher than 1 by 0.56, so that's the 56%. So whenever you have a relative risk, you have uh, the options of doing the interpretation. So this is my recommendation for you. If your relative risk is greater than 1, but it hasn't reached 2 yet, so مثلا 1.3 ولا 1.8 ولا 1.6, one thing you could do, you can do -1 لكل وحدة منهم لهول. The value you get, you multiply by 100, so this is 30% increase in risk. This is 80% increase in risk. This is 60% increase in risk, and therefore the interpretation would be those exposed have 30% more risk. Okay? Once you reach the 2, it becomes harder to do that. Therefore, once you reach 2, or 2.1, or 2. Etc., we say the risk in the exposed is 2 times greater than the non-exposed. It's 2.4 times greater than the non-exposed. It's 3 times greater than the non-exposed. Okay, so you use your relative risk and you say the risk in the exposed, بتحط relative risk is 2.3, 2.5 greater than those non-exposed. I could have used this same way for 1.3. I can say the risk in the exposed is 1.3 greater than the non-exposed. It still works. So the second way works anyway. This way only works if you're less than 2. Because once you reach the 2, and if you don't want to do the 2 minus, بتصير hard to interpret when people start getting confused. هيدا قلنا if your relative risk is greater than 1. If your relative risk is less than 1, okay, so maybe your relative risk is 0.7, maybe it's 0.5, maybe it's 0.2. كمان عملوا -1, -1, -1 وكمان حلوا percentage. So this becomes 30%, this becomes 50%, and this becomes 80%. Okay, so same thing as we did over here, but you're not going to say greater, you're going to say lower. So you're going to say the risk in the exposed is 30% lower than the non-exposed. Okay? And so that's an easy way to do the interpretation for the relative risk. Okay, so لكن we calculated the relative risk مع confidence interval وعملنا interpretation for that. Now the confidence interval are the confidence level of the confidence interval. يعني 95%. أنا لحد هلا I was talking only about 95, but in fact there's 99% and there's 90%. The width of the interval, يعني how precise it is, and the sample size are related to one another. Let me explain why. So let me go back to the formula of a confidence interval, and this formula is true everywhere. So remember إن في عندكم population, and out of the population you take a sample. Okay. Now in the population there is a real value. There is a real value that you're interested in knowing. You calculate the estimate of that real value in the sample. And therefore you take that estimate. This is your point estimate of this real value. However, you can create a confidence interval around it by, as I've said previously, you take the estimate and you go down and you go up and you create an interval, and then you say I'm 95% or 90% confident that the real value is inside. So how do you build that interval? You build that interval by adding and subtracting from your estimate this distance. Now, what are the factors that are inside? How do you determine the distance? So to determine the distance, you're adding and multiplying the distance in Lalakin. This distance is equal a certain test. So it could be a z test, it could be a chi-square test, it could be a t test, multiplied by something called a standard error. هول مع بعضهم, they give you that distance that you're going to go up and down, okay? Now the distance is only half the width of the interval, okay? Because you need to go up and to go down. So that distance is made of two elements. Element number one is the test, and element number two is the standard error. A standard error general formula, without going into details, is something divided by sample size, and you take the square root of all of that. The point being, sample size is on the denominator in the standard error, and therefore كل ما sample size increased, the standard error as a whole decreases. Therefore, as the standard error decreases, what happens is that this distance decreases, and therefore the width of the interval decreases. And when the width of the interval decreases, بنقول the interval now is more precise. Okay? كل ما interval is narrower, it's more precise. Think about it. You're asking your friend when you're coming, when are you picking me up? And they may say between 9 o'clock and 10 o'clock. Okay? See how wide that interval is? So you tell them, can you be more precise? And they say, okay, maybe between 10:20 and 10:30. Okay? They reduce the interval from a whole hour to 10 minutes. By reducing the interval, they became more precise. Okay? Now let's talk about the other element of the distance. The other element of the distance is the test. The more confident you want to be, so maybe you want to be 90% confident, maybe you want to be 95% confident, and maybe you want to be 99% confident. The more confident you are, the larger the test is. Okay? يعني كل ما بدنا كل ما الconfidence تكتر, the test becomes larger. وكل ما the test becomes larger, the distance becomes larger, and the width becomes larger, and the precision becomes smaller. Okay? Think about it. If I ask you how confident are you that you're going to get 80 on the exam, how confident are you're going to get between 70 and 90 on the exam, and how confident that you're going to get between 50 and 100? Obviously, you're going to be much more confident between 50 and 100. كل ما وسعنا الانترval, كل ما you are more confident, less precise. Okay? So precision and confidence are one against the other. So let's go back to our lecture and see if we can continue. لكن قلنا the confidence and the sample size, okay, are two elements that help you determine the width of your confidence interval. The bigger the sample size, the narrower the interval is, and the more the interval is precise. Okay? There are two elements that affect the size of the لكن قلنا confidence interval: sample size, as I mentioned in a minute, and the level of the confidence. Higher level of confidence yield wider confidence intervals and less precise. So maybe this is a 90% confidence interval going from 1.4 to 2.8. A 95% confidence interval, it has to be wider from 1.1 to 3.1. Okay, for the same data, طبعا I don't change the data, still staying with the same data. If you calculate a 90 ولا 95 ولا 99, it becomes wider and wider. And again here I need to point out something. If you're using the same data, you have to watch out how the confidence interval is behaving. So let's sticking with the example of the relative risk. Okay, so this is a relative risk, and this is maybe 1, this is 0. Okay, so if you build a 90% confidence interval, طلع هون هيدا 90%. Okay, if you use the same data to calculate a 95% confidence interval, remember the midpoint has to be about the same, but the distance grows. So you're going to go a wider distance on this side and a wider distance on that side. Okay? So notice that when you're going from 90 to 95, إلنا the width becomes larger على شرط that the lower limit goes down and the upper limit goes up. And if you're also interested in calculating, let's say, a 99% confidence interval, بعدنا عم نحكي the midpoint is the same and you're going to travel a larger distance up and a larger distance down. So now your 99% confidence is even wider. بس كمان بعده الشرط that the lower limit goes down and the lower limit and the upper limit goes up. Okay? يعني if the 90% confidence interval for a relative risk, for instance, كان 2 والupper كان 3, okay, a distance of 1. If you want to calculate a 95% confidence interval, an answer that is 2.5 ل 5.5 is wrong. مع انه هون الwidth is 1 وهون الwidth is 3. So really the width did grow from here to here. However, what is wrong is that this 2 went up to 2.5, which as we just explained should not happen. The 2 should go down. It cannot go up. يعني the limit of an interval as you're going from 90 to 95 to 99, they have to move into opposite direction. Okay, so that's what I was trying to explain. So كلمة you want a high level confidence, the interval is going to become wider and you lose precision, provided that if you're using the same data, the limit have to move from opposite direction. يعني 1.4 goes down, 2.8 goes up. Okay, وإذا بدكم تجيبوا 99, the 1.1 has to go down and the 3.1 has to go up. The second element is sample size. Bigger sample size yield narrower confidence interval, more precise. So here's a 95% confidence interval and here's a 95% confidence interval. My sample size here is 100, my sample size here is 200, provided that both of them have produced the same relative risk. The confidence interval is the first one is 1.4 ل 2.8. The second one, بما أنه sample size is larger, then it has to be a narrower confidence interval. And to become narrower, the two limits have to move towards one another. يعني ال 1.4 goes up to 1.8 and the 2.8 comes down to 2.4. And then you have a narrower confidence interval, more precise. Okay. All right, so here's a table, and in this example, I ask you to calculate a relative risk and to do an interpretation. That is going to probably be on your assignment. Let's continue. So, so far we're talking about relative risk. Enough to be able to calculate a relative risk, you need a design that allows you to do so, يعني prospective design. If you're working in a cross-sectional design, then everything we talked about the relative risk is done the exact same way. Everything, except we do not talk about relative risk. We talk about prevalence rate ratio or relative rate ratio. Okay, PRR or RRR. Okay. However, everything remains the same. The interpretation is no longer the risk is double. You see the prevalence is double. You don't say that the risk is increased 20%. You say the prevalence is increased 20%. Okay? Everything else is the same. Last but not least is the odds ratio. This is why I introduced the concept of odds. And this is basically used, most widely used, when you have a design that is retrospective. However, it turned out that an odds ratio, you can calculate it in any kind of design. Whether it's prospective, retrospective, cross-sectional, you can calculate it in any kind of design. Okay, so again, here's the setup of a prospective design. Okay, prospective, and the exposed when they're not exposed. And over here I'm calculating the odds of كيف الريسك كنا بنقول risk in the exposed هون the odds of in the exposed odds of the disease in the exposed. So بدل ما أحط A over A plus B, I'm just going to put A over B. And instead of doing C over C plus D, I'm just going to do C over D. So I have the odds of the disease in the exposed, odds of the disease in the not exposed, and then you do the odds ratio. يعني odds in the exposed على odds in the not exposed. And by doing so, you notice that it becomes easier to look at. It becomes AD على BC, يعني A times D divided by B times C. All the opposite to one another, you multiply them and you put one on top of the other. The interpretation of the odds ratio, it can be calculated in cohort design and in case control design and cross-section design. The interpretation differs, okay? حسب, if you're doing a cohort design, the interpretation is a bit different than if it's a case control design ولا it's cross-section design. In this course ما حنفوت بالتفاصيل how different they are as interpretation. We're going to keep that for next year. Suffice here is that to know that when you calculate an odds ratio, you can do the interpretation the way you do a relative risk, but do not say risk, say odds. So كنا نقول the risk is doubled in the exposed than the non-exposed. Now you're going to say the odds are doubled in the exposed versus the non-exposed. كنا نقول the risk decreases 20% in the exposed versus the non-exposed. You say here the odds is decreased 20%. Okay? So here's an example. This is a case control example, a retrospective. I have 100 lung cancer, 100 controls, and then I'm looking retrospectively at their exposure. So out of the 100 cancer cases, 70 were exposed versus in the controls only 30 were exposed. And now the odds ratio is calculated using that form. 70 times 70 divided by 30 times 30, and you get an odds ratio of 5.4. And therefore, you talk about the odds of smoker among lung cancer cases is 5 times that among controls. Okay, so 5.4 times greater than. Remember, we're not supposed to calculate the relative risk in a retrospective design. However, if we were to calculate, it will be 2.3. However, this number is inaccurate and wrong, and I'm going to show you why it is wrong. So you can actually try to do that on your own. As an administrative decision, we decided to take double the number of controls. So make this 200, make this 60, and make this 140. Recalculate the odds ratio, it's going to come up exactly the same. Recalculate the relative risk, you're going to see that the relative risk changes. Okay? لأنه the design is built in such a way that you are deciding on how many cases you have and how many controls you have. And therefore, you're dealing with set of cases and set of controls, and you're not allowed to calculate the relative risk. We're going to talk more about that next year, but for now, just remember, in case control design, we do not calculate relative risk, we calculate an odds ratio. Continuing with our example, the odds ratio came out to be 0.5.4. The 95% confidence interval is from 2.95 to 8.89. Again, if I want to interpret it to be statistically significant ولا لا, do I look for if the confidence interval crosses 1 ولا crosses 0? Ask yourself, an odds ratio, is it a ratio or is it a difference? By the name, it is a ratio. And therefore, value 1 is indicative of no association. يعني the null hypothesis بتقول the odds ratio in the population is equal to 1. And therefore, we're going to look if the confidence interval crosses 1. It does not cross 1, and therefore it's statistically significant. And we say we are 95% confident that the real odds ratio, or the real increase in odds in the exposed, is 3 times greater, 10 times greater than the non-exposed. And 2.95 is almost 3, and 9.89 is almost 10. So with rounding, we can talk about the odds ratio in the population being anywhere between 3 to 10. So here's a table. Come in here. I'm looking at a case control design. The cases اللي عندهم internal bleeding, the controls اللي ما عندهم internal bleeding, and I'm looking at whether they were taking PPI ولا لا. And I'm asking you to calculate an odds ratio and to do the interpretation of that odds ratio. That's probably going to be also part of your assignment. Okay, more measures of association. There's a measurement of association that is specifically used in survival analysis. Survival analysis and the analysis that are mostly used for cancer study. And typically, what happens is you're going to look at a set of patients, some treated and some non-treated, and you're going to follow them up to see what's going to happen to them in terms of reoccurrence of the disease, well, dying. If it's dying, then it's called overall mortality, overall survival. Actually, we look at those that do not stay alive. So بيطلع على overall survival. أو مثلا time for remission. So you're looking at how long it takes them for remission out to relapse. So in this example, you're not only interested in the outcome, if the outcome occurred ولا لا, but you're also interested in how long for the outcome to occur. Okay? So خليني أعطيكم a quick example. Let's see if I can help. So let's suppose I'm looking at a sample of cancer patients. So over here, this is time down here, and over here is percent alive. Okay, so surviving. So at the beginning, everybody is alive, and I'm comparing two drugs. So the first drug, maybe you can after 5 years, everybody starts being alive, and as time passes, they die out very fast, and you reach a very small proportion of those alive at the end of the 5 years. Another drug, actually, the survival is quite different. They die out at a much slower rate. Okay, so though at the end maybe they are the same after 5 years, however, their survival distribution is quite different. Those tend to survive for a longer period of time than those. And therefore here you're not only interested in how many are going to be alive at the end, maybe لأنه ما في فرق بيناتهم, rather you're going to be interested in um, how long it takes them to die. So as I said, this is like more a survival analysis. And in that design, in this type of study, we calculate something called the hazard ratio, which كمان it's a ratio, and it does look like a relative risk, and we interpret it the same way we interpret a relative risk. You're allowed to say risk when you're looking at a hazard ratio. كمان بنعمل له confidence interval, and we try to see if it crosses one ولا لا. So let's go over the slide. Indicated survival population. The design, it's more like an RCT auto cohort design, mostly used in cancer patients. We're not going to go over the theoretical background, but the idea is you're interested in the occurrence. كمان في عنا loss to follow-up censorship, which is part of the calculation. But basically, as I said, you're interested in the time. So four things we look at: the median survival time, the clinical median. This is the 50th percentile, that values that comes right in the middle of the data. We're interested in the survival curve. We're interested in survival rate at a certain point in time, and also the hazard ratio. So for survival time, this is where the 50% of the population is dead and 50% are alive. So over here I have examples coming from the lung cancer examples, and they talk about the يعني هو مثلا stage 3B for non-small cell. The median survival time with treatments is 13 months. Yani by 13 months, 50% of treated will be alive and 50% would die. The second outcome in the survival curve, this is where you graphically are going to look at the survival, مثل the one I showed you at the beginning. مثلا here, everybody is alive at the beginning, and as years are passing, they're dying. Okay, and using that technique, you can look at second year what percent are still alive. Okay, at 6 years, what percent is still alive. Actually, you can do it the other way around. You can ask yourself, like, at 50%, which is right here, تعملوا extrapolation, and then you go down and بتقولوا the median survival is 5 years for this specific example. This is كمان a survival curve. However, this one shows the censored cases, يعني those that were lost during the study. So survival curve continues. The curves of different population can be compared. If the line crosses, this typically means that there is no statistical significance between the two curves. On the other hand, when the lines do not cross, there is evidence that there is statistical significance between the two. So this is an example of three survival curve, and the difference between them three is the number of positive axillary lymph nodes. So those اللي عندهم 1 to 3, those اللي عندهم 4 to 9, وthose اللي عندهم 10 plus. And the survival time is going from 0 all the way to 20 years. And you can see that the green one, those with a lot of lymph node positive, is dropping much faster than the other two. It's not crossing much with the other two, and therefore you can declare that there is statistical significance with this survival curve versus the other survival curves. كمان this is another example. So here's again a very similar study. This time we're looking at the positive بس مش axillary lymph node ratio. So طلعنا على we took the positive على التوتال وطلع less than 25%, 25 ل 49%, 50 ل 74, and more than 75%. And therefore we ended up with four different survival curves. And by comparing any one to the others, you can figure out if it's statistically significant or not. Obviously, the blue one is not crossing with any of the others, and therefore, if you look at the comparison between the blue and the yellow, the p-value is statistically significant. The blue and the green, the p-value is statistically significant. The blue and the orange, the p-value is statistically significant. If you compare the yellow with the green, they're crossing quite a lot. So the yellow versus the green, it's not statistically significant. The yellow مع orange كمان they cross over here, therefore they're not statistically significant. Last is the green مع orange. So the green مع orange is crossing here and it's crossing here, and therefore if you look at the p-value for these two, they're not statistically significant. كمان here's a third one, and in this case, and I ask you in your opinion, which of these stages have a different survival curve and which one is better or worse. So I'm going to leave this one. I'm not going to answer that question. بترك لكم إياه للassignment. Number 3 is asking what is the survival at a certain point in time. So what is the survival at 1 year? What is the 3-year survival? What is the 5-year survival? So come in looking up on the web. You get this. This is the survival for different cancer, but they're looking at the 10-year survival. So prostate cancer, the 10-year survival is 84%. يعني 84% of prostate cancer patients survive up to 10 years. Lung cancer is only 4%. يعني only 4% of lung cancer patients survive up to 10 years. Again, this is coming from a published study that we did. Over here, for example, you can look at something like tumor size. Okay, so the tumor size is less than or equal to 2 centimeters, 2 to 5 centimeters, and more than 5 centimeters. And what we calculated is the 5-year survival and the 10-year survival. So you can see that 82% of this group survives up to 5 years, 75% survive up to of this group survive up to 5 years, and for that group 71% survive up to 5 years. If you want to figure out the 10 years, you can look at this column here and you can see. كمان مثلا example whether they received radiotherapy ولا لا. So what is the 5-year survival for radiotherapy, those that received, and what is the 10-year survival? Same thing for those that did not receive radiotherapy at 5-year survival and 10-year survival. Okay? So the last piece in dealing with survival analysis is the hazard ratio. مثل ما قلنا الhazard ratio works very similarly to a relative risk. If it's equal to 1, معناتها indicative no association. Greater than 1, there is increased hazard. Less than 1 is there is decreased hazard. And we also tested using p-value ولا confidence interval. So as I said, you can produce the hazard ratio using different statistical technique. One of them is the cross proportion hazard model. في كمان the I'm trying to remember the name. I'll remember it and I'll tell you. If you're ever interested in working with survival analysis, you'll hear about the cross proportion hazard model, or the other one which I can't remember for sure now. I'll remember it. And basically, you're going to see something like this, where, مثلا, if you want to know who is at a higher hazard of dying, men or women, the hazard ratio is 0.80. The 95% confidence interval is 0.35 all the way up to 182, crossing value 1, and therefore not statistically significant. And you can tell by looking at the p-value as well. Okay. However, if you were to interpret this, you would say that men, sorry, this is men 0.80, men are at a 20% lower hazard of dying at any given point in time than women. But it's not statistically significant, so we cannot say this. Okay. And you can look at all the confidence interval and you can try to figure out which one is statistically significant and does it match the p-value. Over here, this is come in an example where I can probably use it for an assignment. In this, I'm asking what are the median survival time for each of the three groups? Do you expect them to be statistically different, and explain? So come in, we'll leave that. So, as a summary, relative risk and hazard ratio can only be calculated for cohort and RCT. Odds ratio can be calculated for any design. Prevalence rate ratio can be calculated for cross-sectional design. Relative risk and odds ratio are not the same thing and should not be interpreted the same way. Odds ratio has a different meaning according if you're doing a cohort ولا case control study. ما فتنا فيها. We'll do that next year. A relative risk hazard ratio, prevalence rate ratio, and odds ratio behave the same way. One, when they're equal to one, yani there is no association. Greater than one, positive association. Less than one, negative association. The null hypothesis always states that there is no difference, and therefore always states that the real value in the population is equal to one. The null hypothesis, as I said, always declares that these are equal to 1. It can be tested for statistical significance either using the p-value or the confidence interval, and we discussed all of that. So this concludes this lecture. Thank you very, very much for your time.